So, now we are going to discuss specification development. What is specification first of all? So, specification is basically a precise description of the product from the viewpoint of performance, ergonomics, aesthetics, safety, disposal, cost, etc. That is what specification basically means. Specifications are translation of customer need in technical terms. So, earlier we have discussed about customer need, and when these needs are actually translated or transformed into technical terms, then we call it a set of specification. Now, within the specification, we can have specification regarding technical aspects of the product, that could be ergonomics aspect of the product, safety, maintenance related aspect, and also disposal. All of them is a part of the specifications. Now, each specification must have a metric and a value. Like example, strength of a fabric. Strength is the metric, whereas if the strength is 150 kg force, then the 150 is the value, and the unit of this value is in kg force, or we can have in Newton. So, strength is a metric, and force, the value of the force or the value of the strength, in this case 150 kg force is the its value. So, strength is the metric and 150 kg force is the value. How do you develop specifications? If you look at this flow chart, and we see that the starting point is the need. So, need is the starting point. Then we have to identify the matrices for these different needs, and then we have to assign values. Unless the values are there, we will not be able to really do the design. And once we assign value for different needs, that becomes our specifications. So, that for each need, there has to be a corresponding matrix and value. Similarly, different needs will have different matrices or different values, and this entire chart will then be called specification. Now, the most important aspect therefore is translating the need into specifications. Now, customer needs are basically provided in layman's language, and therefore, it gives very little guidance about the way to design and engineer a product. A set of specification gives a precise measurable detail about the product. So, that is what is required before we start the real designing process. The set of specification is expected to satisfy the customer needs. So, keeping in mind the customer need, the specification has to be set up, and we have to make sure that the specification is satisfying all the needs of the customers. As an example, let us say the customer need if the jacket is not warm enough. So, this is the customer statement. It is a winter jacket and the need is what is the customer says the jacket that he is using is not warm enough. Now, the corresponding specifications for the warm is the metric will be what is insulation, and the unit of insulation is either in tog or clo. So, the matrix is insulation, unit is tog and clo, but the value is not given. So, the value we have to assign. So, we have to see what is the existing value, that is the insulation value in terms of either tog unit or clo unit of the existing jacket, and then we have to make sure that to make him feel warm, how much value is really required, and the value that we require will depend upon the climatic condition in which the customer is going to stay. So, for a customer who is using the jacket in a suppose in a mountain area where the temperature is much less in comparison to the plain area, the requirement of the insulation value will be higher there, whereas a person who is staying in the plain area, the requirement of insulation value will be less. So, need or also it can be called performance characteristics. Performance characteristics describe its intended functions and expectations of the user. So, sometimes the designer himself also can find out or can assign the various characteristics which is should be there in a particular product. Like they say performance characteristics, primary performance characteristics in a raincoat. The moment we say it is a raincoat is a product, the performance characteristics of the product is going to be waterproof capability. This is obvious because from the very name of the product we can say this must be the most important performance characteristics of the product or most important need of the product, that it should protect the person from the rainwater. So, the product has to be waterproof, that is the first and foremost performance criteria or performance characteristics. That could be others also, but just as an example we have given just only one. Fireman's uniform, the performance characteristics will be flame retardancy, that it should not catch fire when the fireman goes inside the fire. For bed sheets which are going to be used in hotels or hospitals, and bed sheets which are going to be used in domestic use, their characteristics will be little different. In the hotel or hospital industry, the bed sheets has to be very durable. Why do it need to be more durable? Because it is repeatedly washed. Every day the hospital bed sheet or hotel bed sheets are taken out from the room and washed. So, therefore, the durability of the product is very important there, and durability is a performance characteristic which is difficult to measure also, because durability depends upon so many other factors. So, we will see that how to or what parameters going to affect the durability of a product. The other thing is, like for apparel product, another example, style and fit are something very desirable characteristics, but they are also very difficult to define and measure. So, therefore, there are certain performance characteristics in a product that a consumer or the customers can expect, but some of them are very difficult to really measure. The style is something which is very difficult to measure. The pride in owning something is something very difficult to measure. The fit to some extent is still measurable. So, anyway, so these are some of the example of performance characteristics or most important need of some products. Now comes development of target specifications. So, it is established without knowing the constraint of the technology first. So, we first try to develop some target specifications without bothering about the constraint of the technology that is available with the designer or with the production team. Some specifications may not be achieved and some may exceed depending upon the product concept. So, this is also possible that some specification may be achievable and some may not be achieved at all, or sometimes even then we should start with some specification which we will call target specifications. And since some of these specifications may not be achievable, therefore, target specifications may need to be refined after the product concept is developed. So, once the concept is developed, then if we feel that some of the specifications are difficult to achieve with the existing product concept, in that case only there are two alternatives: either you change the concept to achieve those target specifications, or we change the specification. All depends upon the other aspects also. We have to look into that, we will come to that. But what is important here, that sometimes the target specifications we need to further modify it or define it depending upon the product concept. So, what are the steps to establish the target specification now? The first step is prepare a list of metrics satisfying various needs. So, we have to have a list of needs, the technical needs. So, customer need, conversion of customer need or transformation of customer need into technical need of the product. And now, for each of those needs, we have to find out what is the corresponding metric which will satisfy the needs. Then we have to look for benchmarking informations. So, collect competitive benchmarking informations about the values of the metrics which are going to satisfy different needs. Then now set ideal and marginally acceptable target values. So, that means we are setting a range, that this is my ideal value, but this value is, even if it is little less, still I will be able to accept it. So, marginally acceptable target values also we can put there. So, this is regarding the values. Then comes reflect on the results and the process. So, we keep doing it so that we finalize the target specifications to start with. So, marginally acceptable values are those values which we have to somehow, this is the minimum that we have to achieve, otherwise we know the product is not going to function or product is not going to sell. So, therefore, marginally acceptable values are those values below which we cannot go. But the ideal values may be little more than this. So, we must have ideal values and marginally acceptable values for different needs. So, therefore, we can say the steps are need to matrix, matrix to value of the metric, collection of benchmark information, and when we try to find out the value of the metric, calculation may be based on analytical and statistical model. So, from need to metric, then what are the values of this metric? There comes the real challenge. Sometimes we try to collect benchmarking informations. How do I collect it? We will come to that we can take competitor's product and analyze that and get it tested and find out the values. The other thing is that we use mathematical model or any other analytical model which is available. So, first step is the preparation of list of metric. Here we need to have very a knowledge about a technical knowledge about the relationship between the need and the corresponding metric. The relationship between need and the metrics is central to the concept of specifications. And who has this idea? It is the person with the domain knowledge can only tell us that if this particular need has to be satisfied, then what are the corresponding metric for it. We will come to that in next few slides to make it much more clear. We have to contemplate each need and consider what precise measurable properties or characteristics of the product reflects the degree to which the product satisfies the need. So, what are those properties of the product that satisfies the need? That is where lot of thought processes go on. Let us suppose an example. The need is comfort of an uniform or in an uniform. So, comfort is a very general term. No? Those who are familiar with this comfort from technical point of view, to a layman's comfort is a very general term. They say it is not comfortable, it is comfortable. But if and comfort by itself is difficult to measure or quantify, though there are people are trying to measure it. Now, this comfort, why it is? Because comfort is a function of breathability. And what is breathability? It is basically moisture, vapor and air permeability through the fabric. That is what is basically breathability. So, comfort depends upon breathability, and breathability is a very general term. It is not a really very scientific term. The more scientific term for this is moisture vapor transmission and air permeability through the fabric or through the garment. The other part which may affect comfort in a garment is the ventilation. There is in the designing of the garment, whether there are vents are there or not. Through the vents, the moisture laden air which is close to the skin, that may escape. So, therefore, ventilation also matters from the comfort point of view. The other thing is fit, whether the fit of the garment, in this case the uniform, it is a very tight fit or it is a loose fit, that also affect the comfort of a uniform. So, as you see, the comfort is a function of breathability, which in turn is a function of moisture vapor and air permeability. It is also a function of ventilation, is also a function of fit. So, we can keep adding, it may be a function of the stretchability of the uniform. So, there are many, that means one simple need have multiple metrics. So, comfort is one need, but the metrics for comfort is going to be properties related to breathability, ventilation, fit, stretchability, things like that. So, guidelines for developing a list of metrics. First of all, metrics should be complete. That is, ideally each need should have at least one metric. The value of that metric would correlate perfectly with the need. However, it may not be always possible. As told, for the need of comfort, there cannot be one metric. We have to go for multiple metric. But there are certain need for which there may be one metric also. So, it all depends. Metric should be dependent and not independent variable. Metric specifies overall performance of the product, and therefore, it is a dependent variable, because it depends upon other properties or constructional parameters of a fabric or of a garment. By using dependent variable for the specification, designers have the freedom to achieve the specification using the best possible approach. So, the designer has the option, or they have the freedom to achieve a certain specification by various combinations. Like, suppose I want to achieve a certain strength in a, let us say, yarn. Now, I can achieve that value of strength. So, strength is a metric and there is a certain value. It has to be, let us say, 300 gram strength, I need 300 gram force. I can achieve this by playing with what? By playing with the strength of the fiber. So, that is a variable for us. I can also know the change the strength by the twist. So, twist is another variable. I can also change the strength by the count. So, count is another variable. That means, the target strength can be achieved by playing with these three different variables: strength of the fiber, then the twist, then the count of the yarn. So, these three variables I can have different combination of them to produce a yarn which will satisfy the requirement of the strength. This is what it is. Next is, some needs may not be translated into quantifiable metrics. As I said, some of the needs are such that you just can't quantify them, like pride in owning a suit, a car, or a wristwatch. So, there is a people have a sense of pride in owning something, and here is a kind of weakness which is there in the human being. So, how do you quantify the pride? This is very difficult. What could be the metrics for it, which is related to pride? So, this is something where there is a difficulty. the pride in owning a suit, a car, a wristwatch, but that is what is also could be a part of the design. So, a design engineer has to design in such a way that it gives pride to the person who is owning it or who is using it. Metric would be subjective and would be evaluated by a panel of judges. That is in this particular case. Here there are many things which may affect the pride. So, this type of thing is not measurable. So, we have to only basically go and ask the people that how much pride he feels in owning this. So, it is very, very subjective in nature and it can be judged by a panel of judges only. Those who are in that particular area, they can only say something about the pride in owning something. Maybe the cost is one metric. If it is very costly product, people will feel that yes, I have the money to buy it, rest of the people cannot own it, and therefore he may feel that there is some sense of pride in owning this because others cannot really afford it. Like people feel proud in owning an Apple computer. So, this particular aspect of human weakness has been exploited by the manufacturer of Apple products. Next thing is need metric matrix of a workwear, let us say. One example, this is something which the designer has to first develop. Need metric matrix. So, on the if you look at this table, see needs are listed on the very first column. 1, 2, 3, 4, 5 needs are mentioned here, and on the rest of the columns are different metrics or property of the product. So, we are trying to relate each of these needs with the property. Now, what we have done it here, that the properties have been now classified: transmission property, thermal property, chemical property, mechanical, aesthetics, the garment. Suppose it is workwear, it is a garment. So, garment related characteristics also will come. About maintenance, we have also written something, washability. So, different the metrics have been classified here. Now, let us say the first need, let us look at it, the comfortable to wear and work. That is the need of the workwear for any person who is using it. Now, what properties are relevant for comfortable to wear and work? If that is what is the need of the user. So, whatever the tick is there, they are the relevant property. Like air moisture permeability is important, air permeability is important, resistance to heat is also important, then ventilation from the garment point of view is important, then pockets to carry tools and all should be there. So, that becomes important, number of pockets which are there, the feet also becomes important. So, we have a list of properties on the right hand side, and whatever we feel that they are relevant, we just tick them. So, we see comfortable to wear and work depends upon these aspects. These are the relevant metrics for it. If you take the second one, protection from acid or heat and abrasive damages, then what are the relevant thing from protection point of view? Resistance to heat, there is a tick. Resistance to acid, there is a tick. Abrasion resistance, which is a mechanical property, there is a tick. strand resistance, there is a tick. So, these are the relevant. Then we come rest of the property. If we feel they are not suitable, we don't put any tick there. So, these are relevant for the protection from acid, heat and abrasive damage. The other important, take another one, let us say durability. Anything that we buy and use it, we feel that it should be durable. So, durable is a very general term also. So, durability, somebody expects it should be durable for 1 year, someone may feel it is should be for 3 years, someone may feel up to 5 years. So, durability cannot be measured simply. So, the corresponding metrics which may help us to make a product durable, what are those? One is the abrasion resistance. Abrasion resistance is something we can measure. So, the tick is there under abrasion resistance. Then there is a tick under tear strength of the fabric, that is also is, these are the mechanical property. Obviously, air permeability has nothing to do with durability, or moisture permeability has nothing to do with durability. So, therefore, you cannot have tick under transmission property of the fabric. So, durability depends upon the other thing is color fastness, because sometimes if the color fades away, we reject the product, we do not feel to use it again. No. So, therefore, even the product mechanically may be strong enough to be used, but just because the color has faded away, so it is no more giving me a pleasant look, so we discard it. So, therefore, that also may be sometimes a reason for durability. So, how quickly the color fades? If it fades too quickly, that means the product is not durable. Then seam strength may also come. So, these are the things which one has to keep thinking, and he can put tick marks under it. So, like that we make a chart, we understand therefore that these needs will be satisfied by these are the corresponding metrics. And who can do this? Someone who has knowledge. So, a domain knowledge is therefore becomes very important here. When we go to the next step, collection of competitive benchmarking informations, that is, we have to assign now values. So, while trying to assign values, let us say air permeability. So, how much should be the air permeability value? If I know this value, then I can only think of designing a fabric which will give me that sort of permeability value. So, first of all, we need to know what should be the value, and what is the easiest way to do it, that you try to collect competitive benchmarking informations. So, unless the product enjoys complete monopoly, a comparison between new product and the existing ones is to be carried out. So, we buy products made by different manufacturers and test the different properties which we feel relevant, and then we make a chart and write down the values one after the other. So, a chart having metrics and values of the competitive product is to be made. At times, the values may be need to be determined through analytical means or carrying out experiments. So, we have to sometimes may we need directly measure it because of an instrument, sometimes we have to indirectly we have to find it out, or somehow we have to do some specially designed experiment to find out the values. So, it depends. Then comes this set of ideal and marginally acceptable target values, so that the designer has a choice. Ideal value is the two types of target values could be there. Ideal is the best result the team would hope for. If I can achieve this, that is what is ideal. But marginally acceptable value is value of the matrix that would barely make the product commercially viable. And if we fall below this, or if we go beyond this, then it may not be commercially viable. We will not be able to sell it at all. That is called marginally acceptable value. Okay. Now, expression of values of the matrix. There are 5 different ways of expression. One is at least x. What does it mean? This gives a lower bound, but higher is still better. Now, what is the example for this? Let us say strength. Strength is specified. Let us say strength of the fabric should be maybe let us say 3.5 kg force. So, that becomes a lower bound. If someone can produce a fabric which is more than 3.5 kg force, that will be also acceptable. So, this becomes my at least x type of value. It is a lower bound, that is, we should not fall below this, but anything above it will be always acceptable. At the most x is just opposite of that. This establishes the targets for the upper bound, that is, with smaller the values, better it is. What is that? What is the example for this at most x? Let us say faults in a fabric, that so much fault per meter is acceptable to me. But if it is less than this, it is still better. So, when it comes to level of faults, then this is at most x. This gives me the upper bound. Between x and y, that it states both upper and lower bound for the values of the metric. This may also happen in some situations that there is upper bound and there is a lower bound. That means the value of the metric has to lie between these two limits. Neither it should exceed nor it should fall below the lower bound. So, it may also happen that could be upper and lower bound for some metrics. Exactly x, it establishes a target of a particular value of a metric. This type of specification is to be avoided. This is very, very important, that we try to avoid such specifications, because it puts constraint to the design. When one particular value, it becomes a very constraint for the designer, because he has to achieve that value. Something, a exact value is almost difficult to achieve. All textile products are basically variable in nature. Any property that you measure, it will always vary a bit, and therefore we measure CV values, coefficient of variations, because we know that the kind of fiber that we handle and its properties are not exactly same from fiber to fiber or filament to filament, and therefore, and when it passes through so many processes, finally whatever is produced out of it, maybe a garment, maybe a fabric, maybe some other textile product, there is some variability always will be there. but if we fixed say that this is the value what I need, it is something almost impossible to achieve. So, such kind of matrix, the value of the matrix should be always avoided. We should always give a little range, that it should fall in this range is still okay. So, a set of discrete values, sometimes matrix may have discrete values only, not continuous. What is there in this kind of values, discrete values? Numbers, number of faults is a discrete value, it is not a continuous value, but strength is a continuous value. Strength, extension, modulus, these are all basically continuous. Now, comparison chart of values of matrix of different manufacturers, that is what I was discussing earlier, that once we collect informations from company, from a product made by company A, collect informations regarding different metrics as stated in the different columns. For products made by company A, company B, company C, company D, and then we make a chart as shown it here, then we can really compare between the values, that which company is giving the best value for a particular matrix and which company is giving the lowest value. So, what is the range? So, all these data can be compiled, and based on this we can now design a set of specifications for the product that we intend to design. So, setting of final specification using 5 different expressions, the target specifications is set. It is greater than x, less than x, in between x and y. So, and the device specifications after assessing the actual technological constants and expected production cost. Once we have specifications, now you also keep in mind that what is going to be the production cost and what are the technological constants that we have to achieve those specifications. So, we first develop a set of specifications, and now we analyze it, that do we have a technological constant, that is manufacturing point of view. I may not have the technology to achieve those specifications because I do not have the machines that I need for it. Similarly, other aspect will be the cost part also. So, we have to also work out what is the cost and whether I will be able to sell to the customers or not. So, keeping in mind these two, the specification is again revised. So, finalization and specification is sometimes difficult. So, it is an iteration process, and therefore, sometimes what to do, that trade off become necessary between different technical performance and technical metrics and cost. So, finally, we have to go for a trade off, because all the best of different metrics may not be achievable or will be very difficult to achieve. So, between these technical performance metrics we need to do for some trade off, and the other is technical metrics and the cost. So, cost related aspect also we have to see. So, how the trade off is resolved, then we are going to discuss this aspect now, but before that Let us see the specifications which I lifted from some sources about typical specification of a jute bags. So, jute bags is a technical product. These bags or sacks are used for what? For transporting grains, sugars. For such things we use these bags. Now, what sort of specifications are given, so that we have some real value specification is stated here. So, one is they have given specification related to dimensions of the bag. So, it should have a certain length, certain width, because dimension will decide the volume, and volume will decide how much grain can be contained, whether it is 30 kilo or 40 kilo. So, if I want to carry 30 kilo of sugar or 30 kilo of rice or 30 kilo of any other grains, then that is going to be the typical size. So, therefore, the size is given in terms of dimensions, and if so type A, type B, they have given some sizes, and they have given also some tolerance. As I said, they are not fixed. So, 94 is not just 94, because 94 centimeter exactly outside length will not be possible. So, there is a plus minus 4 centimeter allowance is given, plus 4 and minus 2. That means, it can be little more, but not less. Similarly, for the outside width, it is given 57 plus 4, that means, it can go up to 61. Anything between 57 to 61 will be acceptable, but it should not be less than 57. So, they are basically in a way lower bound specifications. Then they have also given ends and peaks per decimeter. So, end density and peak density also are given, and why they have given it? Because end density, peak density will decide how much will be the gap between the threads, and through those gap whether the grain is going to come out or not. Depending upon the size of the grain, we have to decide the gap that exists between the threads, between the interlacements. This is also specified. Anyway, basically it means the cover factor. Then corresponding mass of the bag is also stated, what should be the weight of the bag, and there the specification you see here, the range is given plus 8% and minus 6%. So, that much variability is accepted. So, mass also has been given, because mass decides how much fiber is there. How much fiber is there will decide what could be the expected strength. Though they have specified also the strength here, that work weight strength is 1570 Newton or 160 kg force, web to strength also has been specified. So, for bag type A and type B, this is for A type of bag and this is for B type of bag. So, these are the type of things ultimately. So, one can say here the customer himself has specified the specification. So, there is no as such that we start with customer need and then translate the need to product need and the product need to specification, not doing. So, directly here the specification has been given by the customer and is given to a manufacturer actually. So, manufacturer is going to manufacture the product to fulfill the specifications. Ultimately, see, designing is one aspect, manufacturing is the other aspect. A designer is not a manufacturer. Designer will actually set out कि like suppose it is given to a designer, he has to find out from here that if specification is giving that the watt per strength should be so much and ends per density also is given 76, then what should be the strength of fiber that he is going to choose? So that is what is one of the design variable, where the strength of the fiber has to be chosen, so that the strength of the watt per strength and wave per strength can be met. That is what we need to find out from here, and the manufacturer will be told that you choose this fiber and process them and make yarns of these counts and then produce a fabric where end density, peak density will be like whatever stated here. So, it is like this. So, see the in this case the back specified dimensions are suitable for packing of wheat, rice and similar coarse grains. If it is fine grain, then probably you have to go for still higher end density or peak density. Otherwise, through those perforations between the threads, some of these grains will be moving out. So, this is one examples which I just stated you. Similarly, that could be others also. Now, we have to say that discuss about this trade-off resolutions, that is, even though there is a sort of specification available with us, we have to see the constraint of the technology and the cost. Based on this, we have to finalize the specification now. So, we have to, for this we need to develop a technical model of the product and cost model of the product, then refine the specifications, making trade-off wherever necessary. So, here comes the model building. One is technical model of the product. This technical model will explain what is this. The other is the cost model of the product. Now, technical model of the products. Technical model helps in predicting the values of the metrics for a particular set of design variables. Inputs are design variables and outputs are value of the metrics. In many cases, analytical models will be available for a small subset of the metrics. If not, physical models are to be built up and tested, like suppose fatigue behavior. Now, fatigue behavior, sometimes what we do, that is may not be any analytical model available for predicting the fatigue behavior of textile products. And let us say which product fatigue behavior will be important. Tire cord is one example. Tire cord is subjected to repeated extensions within the tire when the car is running. And it will be interesting to know the fatigue behavior. Fatigue behavior of a textile rope also will be important. So, the models may not be there, and here we need to go for physical models and then test it to find out whether the given design is going to work or going to give me the satisfaction from the point of view of durability, because fatigue is a source of continuous degradation of the property and which will finally lead to failure, or sometimes DOE, that is design of experiments, can also be employed for such things. Like one analytical model of garment comfort, suppose it is available. So, the model is there, the input is the design variable, the output is performance specifications. Now, design variables, let us say fabric weight, fabric cover factor, design related to size, pattern, etc., feed, ventilations, and we are interested to know the garment behavior in terms of what is the moisture vapor permeability is one output. The other output could be air permeability. This is output number 2. So, if we have a model that relates some of these parameters with the moisture vapor permeability, then we keep changing the values in this input variables to find out what is the output. So, once we have a certain output target, then we can find out what combination of design variable values will give me an output which is going to satisfy the specified value. So, for different performance specifications or different need, we have to find out what is the corresponding design variable, and if we have a model available between these two, then we make use of that model, give the inputs in terms of design variable values and see what is the output, and we keep changing the combination of design variables, the values of design variables, and see how the output is changing and find out what combination is going to satisfy. So, this is how model building is going to help. Another is, suppose for sewing thread. Now, the specification for suppose strength is given, or elongation is given, or friction value is given, or breakage rate is given. Some values have been given already. Design variables for strength could be fiber parameters. We can say fiber strength of the fiber, and we can give input is yarn structural parameter, let us say count and twist, and chemical processing parameter may not be useful for strength. So, then for strength we can use these two parameters 1 and 2. So, 1 that could be sub parameters, fiber parameters which are relevant for strength, maybe the fineness of fiber, the strength of fiber, structural parameters of the yarn could be count, twist, how many plies are there, and that we try to relate with strength. And if that model is available, we make use of the model to find out what combination of design variables will give me the strength that I need. Similarly, for elongation, similarly for friction, where friction is more is dependent on the chemical processing parameters, whether I have used wax, if how much wax I have used. So, friction is going to depend, it depends upon also whether I have used filament or whether I have used spun yarn. Anyway, so these are the things which are used to predict the value of the performance specifications, where the input variables are basically my different design variable. For this analytical model either has to be built, or if somebody has done some research and the models are available in literature, textbooks, we can make use of them. So, another example, let us say, is parachute fabric. The input parameter which are design variables is, let us say, fiber and yarn parameters, fabric structural parameters, finishing treatments, and if the models are there, either analytical model or statistical model or artificial neural network based model or geometric model, whatever is there, you can make use of these models and find out for a certain combination what is the weight of the fabric, and then whether this weight is meeting the specifications value or not, whatever specified values are there. Air drag also has to be, there should be some value, and whether it is meeting the value or not, something like this. So, from these models one can check whether any particular set of specification is technically feasible by exploring different combinations of the design variables. So, if we find that none of these combinations is not going to meet the specification specified value, that means that the specifications is not really feasible, is not impossible to achieve. This may sometimes happen. Suppose I can just, as an extreme example, if I say I need a very strong yarn of strength, let us say gram per tex, 40 gram per tex, extremely strong yarn, and or 30 gram per tex, whatever values, some values are specified. And then say I also same yarn has to be very irregular. I was cotton yarn, I say. So, irregular, the specified in terms of uniformity value, I give a value which is basically means very highly irregular. At the same time, that means I need a yarn, I am saying specifying a yarn which is highly irregular, but at the same time very strong. This is something which is not rational, not feasible, because we have no means. Even if we have a model and we keep trying it with the design variables, we will not be able to find out. There is no such combination which will give me a yarn which is very strong, at the same time very irregular. That means this is not technically feasible, or I expect certain strength value in a yarn and I know that is not achievable, and they say it has to be made from cotton. Obviously, the cotton has a certain strength limitation, and if I expect a strength in a yarn or a fabric much more than that, whatever the strongest cotton can give, then it basically means that this is not something which is not feasible. So, that sort of technical feasibility can be seen. So, this modeling and analysis prevents from setting a combinations of specifications that cannot be achieved. So, sometimes specification may come and we will see that something which is not possible. So, they are not feasible. The cost model is the other model, that is we try to find out what is the cost of the product, and cost have three components: cost of material, cost of fabrications, that is manufacturing cost, and the overhead cost. Very general terms, we can find out what could be the cost. The cost information should include both high and low estimates of each item, and once you have the cost model, define the specification making a trade off wherever necessary. Feasible combinations of numerical values of design parameters are to be determined through the use of technical model and then its cost implications. So, feasible combinations, first we try it out by technical model, and so we see that it is, yes, it is achievable. Then we find out what is the cost implications for this. And then competitive and trade-off map is to be developed. That means, first technical model and then the cost model. Now, we should use the cost model, and then we find out a competitive map. We will just come to that now, and in an iterative fashion the specifications that most favorably position the product relative to the competitors and satisfy the customer need and ensure adequate profit is finally chosen. So, while we choose, these are the three aspects we have to look into. is it satisfying the customer's need or not, how the product is going to be placed relative to the competitor's product, so that people will be attracted towards my product. So that means this is also important for us, and whether by manufacturing and selling it, can I make adequate profit out of it or not. All these three questions need to be answered before a company is going to really venture out for a new design. Here it is given a competitive map or trade-off map. What is there in this map? You see the x-axis we have written performance, and one side is low, right hand side is low, and left hand side is high. And on the y-axis we have cost. So, performance cost, this is what has been plotted here. Now, here all these small circles indicate the competitor's position. Suppose I have there are competitors 1, competitors 2, 3, 4, 5, there are 6 competitors. So, we have found out what is the performance level of those competitors, and then what is the corresponding cost. So, we see here in this curve there is where the competitors are. So, competitor number 1, performance is on the higher side, but cost is also quite high. Performance 2, performance on the high side, cost is also high, but little less than competitor 1. So, this is some we are going to first make a chart like this, and then we drew the curves for our design case. So, we design case for our concept A design and concept B design. What is the performance versus cost curve that is shown here? One is by the hatched line or the dotted hatched line, and the other one is by a farm line. So, concept A and concept B, the performance versus cost curves is drawn and shown here, and at the same time we have given the performance value and corresponding cost for different competitors. The curves drawn are for different design concept. Design specifications are defined, and trade-off can be made in a way that will provide performance advantage relative to the competitors. The other one is, this one is for the ideal values of the specifications. So, if you choose the ideal values, this is my level of performance. At this level of performance, this is going to be the cost. If I am choosing the marginal values, then here is the performance level, and this is the corresponding cost is here. So, I have the idea that if I go for performance level from here towards this side, that I keep on increasing the performance by choosing certain combination of specifications, then how the cost is going to increase, that will depend upon whether I am using concept A design or concept B design. So, the curves are going to indicate that, and this is going to help me in taking a right decision. At what level of performance we should keep, and at that performance level whether it is above my competitors or below the competitor performance, and at what cost I am getting that performance. So, analysis of this particular competitive map is going to help us to finalize the final specifications. Sometimes overall specification to subsystem specifications, no. So, there are certain designs where it is very complex design could be there. In textile also it is there. designing an aircraft is a very complex machine. So, there are so many varieties of components which are there. So, there are so many designers which will be involved in designing such a complex machine. So, there is overall system and there are subsystems. So, in some complex changing product, let us say smart battlefield uniform, the total design is divided into several subsystem designs, and specifications are used to define the development objectives of each subsystem as well as the product as a whole. That is what is required in very complex designing process. And examples of such type of design, let us say smart battlefield uniform. So, these are the technical specifications that is required. The values are not stated here. Able to detect penetration of a projectile, monitor body's vital signs, heartbeat, temperature, breathing frequency, physiological thermal protections, resistance to petroleum products, minimizing the signature detectability. So, these are all highly technical matters. Ergonomics point of view, lightweight of the uniform, which has to be lightweight, breathability, comfortable, easy to wear and take off, and easy access to wound. In case there is a wound, there is injury, the person is should be able to access that wounded region. Safety, flame retardancy, EMI shielding, maintenance, disposal cost, everything should be easy, disposability has to be there, it should be nature friendly, then affordability. So, these could be, you see there are so many things are there, and for each and every aspect probably we have to find out what is the corresponding design objective, how should be the specifications. Monitoring body vital signs, this itself is a subsystem design. Then minimizing signature detectability is another subsystem design. So, this is a complex designing process where so many designs objectives are there. So, we have to basically the entire design has to be splitted into subsystem design, and for each subsystem what are the objectives we have to write down, and what are the your actual requirements there, what are the metrics for that, and what are the values, and then actual designing. So, these are something like this. Let us say this another thing, this is not a complex one now, requirement of a baby diaper. Technical aspect could be absorbency, it has to be leak proof, it has to be lean, not very voluminous. Ergonomics point of view, it could be soft, snug fit. Safety point of view, prohibit rash formations. Maintenance, that is not much because these are basically one use products, and disposal and cost is it should be non polluter, and cost wise it should be affordable. So, these are the requirements or need of a baby diaper. Similarly, need for an apparel fabric, we can also find out the need in terms of functional needs, ergonomics need, aesthetic need. Then garment making up capability for the fabric and its easy care and safety aspect. So, you see that for apparel fabrics also there are so many different aspects which are actually important. With that, we close this session on specification development, and next we will discuss something else in the next lecture. Thank you very much.